Alright, one thing that I want to mention to you, and if you know of somebody that's not here, please spread this word. I don't know if we're going to miss class anymore or not, but considering the craziness of the weather that we're having thus far, I'm just going to go ahead and give you a heads up now, okay? If we have to miss class, I will put the lecture for that class on Integrity, and it will be your responsibility to go on Integrity and listen to that lecture. So, in other words, even if we're not having class, you have class, but it will be on Integrity, and it'll be your responsibility to get on there and listen to it. And when you listen to Integrity, it'll be just like you're in class, but it won't be. You'll be snowed in, iced in, or something like that. Now, having said that, make sure, today preferably, make sure you can get on Integrity and actually listen to a video. Okay? Make sure everything's working so that we're not in panic mode if we do have to miss class. Okay? So I'm just giving you a heads up now. If we have to miss class, the college is closed for whatever reason, then that lecture will be put on Integrity. And it'll be your responsibility to go on Integrity and listen to the lecture. And then we'll come back into classes that we never miss a beat. Okay? Second thing I want to talk to you is the test. We were supposed to have a test today, right? You printed off that schedule? Yes. We were supposed to have a test today. Your test will be Wednesday. That test will cover Chapter 2. Okay? So your test will be Wednesday, and it will cover Chapter 2, and that should get us pretty much back on schedule. Okay? So we won't go off of our calendar that far. Instead of testing today, we'll test on Wednesday. Alright, so let's pick up where we left off, and that is we started solving inequalities. And remember, when you solve inequalities, it's just like solving an equation, except for you have this little inequality symbol. The only difference is at the very end. What do you have to do? Come on. At the very end, when you're solving an inequality, what's the last thing you need to look at? Yes. If you need to flip it or not. If you have to multiply or divide by a negative number in that very last step, then you're going to turn that inequality around. Okay? The other thing that we're going to do is we're going to write our answers. Number one, we're going to find the solution, which would be here. So we'll find the solution, and then we're going to graph the solution. Remember, in 100 in your further math career, we're going to use parentheses and brackets. Remember, parentheses cannot be equal to, and a bracket can be equal to. So we're going to find the solution, we're going to graph it, and then we're going to write an interval notation. This is totally new for you. So let's look at the one on the right and see what's going on there. So to solve this one, the first thing we're going to do is minus 4 from both sides. So we'll have a negative 5x is greater than or equal to 5. And then we're going to turn around and divide both sides by negative 5. So when we do that, we're going to get x is less than or equal to negative 1. So since I had to divide by a negative number, I had to turn the inequality around, and the answer is x is less than or equal to negative 1. So if we put that on a number line, remember on your test, I will have a number line for you. But for our purposes, as far as your study guide is concerned, if you choose to do your study guide, the only number that you have to put on your number line is the number that's in question. So the negative 1 is in question. It is less than or equal to, so we're going to use a bracket. And this one's saying that x can be any number less than or equal to, so we're going to go to the left. So to color that in, you're going to use a bracket, going left, because it is less than. And we're going to go all the way to the arrow, which this time is negative infinity. So to write your interval notation, you can never equal infinity. So you have to use a bracket for your negative infinity. and then go to your -1, and x can be -1, so we're going to use a bracket there. Parentheses on your infinities. Always use a parenthesis on your infinity because you can never be equal to. But when you can be equal to it, such as a -1, that's when you're going to use your bracket. And always remember, we read our graphs from left to right. So when you write your interval notation, make sure you do it from left to right as well. Okay? So there's your inequalities. Any questions? That was a review from a week ago, I know, but. All right, so let's look at the one on the left. First thing you want to do is what? Combine like terms. So we're staying on the same side, so we're just going to combine the -4x and the +7x, and we'll get 3x plus 3 less than or equal to. On the right-hand side, we're going to do the exact same thing. Combine the 5x and the -1x, which is going to give us 4x minus 4. All the simplifying's done. Now all we need to do is get our variable terms on one side and our non-variable terms on the other side. And I'm going to do something that may be against your grain, but see if you can follow along, okay? I don't want to deal with that negative. Because if I bring the 4x to the left, it's going to give me a -x, and then I have to throw in one more step. I don't want to do that. So instead, what I'm going to do is I'm going to minus the 3x. I'm going to take smallest to biggest, which is typically what I do. So now I'm going to have 3 less than or equal to x minus 4. And so we'll add 4 to both sides. And basically what's going to happen is this. 7 is less than or equal to x. Your x is on the wrong side. This never comes into a problem unless your technique for graphing inequalities is to color the way this little thing is pointing. Because if your technique is to color the way this little thing is pointing, then your x needs to always be on the left-hand side. Okay? Your x always needs to be on the left-hand side. So if you solve this down when you're solving inequalities, and you graph by looking at the, what, not really an arrow, but what you would call an arrow, and you color left, make sure you turn your inequality around and say x is greater than or equal to 7. These two are the exact same thing. So now you know how to graph it. So we'll put the 7 on there. It can be equal to, so we're going to use a bracket, and it's greater than, so we're going to go to the right. So we're going to have a bracket at 7. Remember, you're going to read your graph from left to right, so we're going to have a bracket at 7, and then we're going to go all the way to positive infinity and close it up with a parenthesis. So again, beware of that. If you graph by looking at the pointy portion of the inequality, make sure your variable's always on the left. You may want to put a little note in your notes about that. Make sure your variable's always on the left if that's how you're going to read it. Okay, the one on the right. What's the first thing you're going to do? Distributive property. Good job. So we'll have 5x and -20. Now on the next one, make sure you distribute this negative all the way through. So we'll have a -6x and a -12, less than 4. Now we can combine like terms, so we'll have a -1x and a -32, less than 4. So we'll add 32 to both sides. So we'll have a -x less than 36. Now this time we are going to have to turn the inequality around because we ended up with a negative anyway. So we're going to have x is greater than -36. How do we do? You should be working ahead of me, if not right alongside with me. So you should be able to look up here and check your work. All right, so put this on a graph. So we're going to have -36 is the number that that's our starting point. X is greater than, so it cannot be equal to, so we're going to use a parenthesis, and we're going to color greater than all the way to positive infinity. Read your graph from left to right for your interval notation, so you have from -36 all the way to positive infinity, but we cannot include either one of those, so we'll use parentheses. All right. So, again, inequalities are just like equations. just like equations. We're just going to take it a step farther, okay? We're going to, at the very end, pay attention whether we have to multiply or divide by a negative number. And if we do, we're going to turn that inequality around. Then on the test, I am going to ask you to not only solve it, but I'm going to ask you to graph it and write interval notation. Okay? So make sure you're prepared to do that. All right, here's an applied problem. This is an average problem. Remember, for averages, you have average is equal to however many elements you have. We'll say 3 or 4, and then you're going to divide by that many. So you divide up you add up how many you have, and then you divide by the number that you have. Well, for hours, look at the wording. It says Tom has scores of 50, 97, and 84 on his first 3 math exams. What score must he make on his 4th exam? Now pay attention to this. To have an average of 75.2 or better. So we want his average to be greater than or equal to. So now, how many elements are we talking about? 4. And then we're going to divide by 4. So let's replace these variables with what we know. The average that he's wanting is 75.2. Greater than or equal to, we know his first 3 tests, so we have 50 plus 97 plus 84. We're looking for that 4th one, so there's 4 elements total. Do you remember how to solve this? What's the first thing you want to do? Yes, multiply the whole thing by 4. So we're going to have 4 times 75.2. So I get 300.8. Greater than or equal to. Now over here the 4's cancel out. When you multiply both sides by 4, 4's cancel out. So you're going to get 50 plus 97 plus 84 plus x. And if you want to go ahead and put those together, that'd be perfect. $50 plus 97 plus 84. I'm coming with 231, right? And then we're going to minus 231 from both sides. So we're going to have 300.8 minus 231. And we'll get a 69.8 greater than or equal to x. So can you interpret this? What's the minimum score he could make? 69.8. So he's got to, actually that would be, that would be maximum. So anything from there, greater. Actually, y'all didn't even catch that. The average, I was looking at that, that doesn't make sense. It needs to be less than, yeah. So 69.8 is the minimum score, so anything, he needs to make that or anything better. So make sure when you do these applied problems, you check the answer to make sure it makes sense. For example, that one with the inequality turned around, if he had made less, he wouldn't have made his average. That's what made me think, wait, that inequality's backwards. So make sure you check your answers and make sure you got it set up correctly. Alright, so fractions, do you remember what to do? Yes. Right. You should already be working on this. I want you to solve, graph, and write it in interval notation. So the first thing you're going to do, I already heard it, is multiply through by the LCD. What is the LCD here? It's going to be 8. Good. So half of 8 is going to be 4, so we'll have 4m. Plus 3/4 of 8 is going to be what? 6m. Less than or equal to, and then 3/8 of 8 is going to be 3. You can do that all in your calculator. 8 times 1/2, 8 times 3/4, 8 times 3/8. It'll tell it to you. Then what we're going to do is combine like terms, so we'll have 10m. We're staying on the same side, so make sure you don't add the opposite. And then we're going to turn around and divide by 10. So we're going to have m, do not turn that inequality around, is less than or equal to 3/10. So there's the solution. Well, now we need to graph it. Now, we'll talk about this for a second. On the test, the graph is going to have whole numbers from -10 to +10. So if I have whole numbers from -10 to +10, where are you going to put what two numbers are you going to put 3/10 between? 0 and 1. So make sure you can do that. If not, in your calculator, do 3 divided by 10, and it'll give you a decimal, and hopefully you can find that on the number line. But anyway, 3/10 is about right here. M is going to be less than, so we're going to use a parenthesis, and we're going to go less than. Now, if we read our graph from left to right for our interval notation, we'll have bracket, -infinity, all the way to 3/10, and why do I keep saying bracket? Parenthesis, -infinity, all the way to 3/10, all the way, and then close it with a parenthesis. All right, let's look at the one on the right. What's the LCD? Good. See if you can eliminate the fractions. I'll give you 30 seconds. That's how long it should take. All right, so let's see what we're doing. For the first one, for the first fraction, we're going to say 3 will go into 12 4 times, and so what you're going to have to do is you're going to have to multiply 4 times that whole entire numerator. 4 will go into 12 3 times, so that's a -3. Bring that negative down. -3 times that whole entire numerator. Less than or equal to, 12's cancel out, and you just get 5. Now, we're kind of like the problem we did a while ago. We're just going to distribute. So we're going to have 8x minus 4 minus 9x minus 3 less than or equal to 5. Check your signs. Match this step on the board with yours on your paper and make sure your signs are right. Alright, so we're combine like terms. We'll have a -x. We're staying on the same side, so you're just combining. So we'll have a -x and a -7, less than or equal to 5. So if we add 7 to both sides, we'll have -x is less than or equal to 12. Divide through by -1. Make sure you turn that inequality around, so we'll have x is greater than or equal to -12. So if we're going to put this on a graph, -12, we are going to have a bracket. X is going to be greater than, so we're going to color to the right. And remember, for your interval notation, read from left to right. Everybody wants to put those infinities first. Only if it's negative infinity will it come first. If it's positive infinity, it should come last. So we're going to have a bracket at -12 and go all the way to infinity. So again, it's the same thing as solving equations. You just have a little more to do. Questions? Okay. So let's talk about compound inequalities. What's the difference between a simple inequality and a compound inequality? Well, in a simple inequality, you just have one inequality symbol. With a compound inequality, you're going to have two. So basically, you have two inequalities to solve. Okay? Two inequalities to solve. The first one we're going to talk about is called, in layman's terms, it's going to be an AND statement. In mathematical terms, this is called a conjunction. Okay? So if you hear me say this is an AND, This is a conjunction. Those are the exact same thing. Okay, now this is something new. We did not do this in 098, I don't think. So, to solve a conjunction, what you're going to do is you're going to solve both inequalities separately. If you have a conjunction, either you will see the word and, or you won't see anything at all. Okay? This is a conjunction because I see the word and. This is a conjunction also because I don't see any words at all. But I do see two inequalities. So since you see two inequalities, this is a compound inequality and this is a conjunction. Now in a minute we're going to talk about something that's called an OR statement, a disjunction. With an OR statement, you have to see the word or. So let me give you a big hint, okay? If you don't see the word or, it's an and. Okay? If you don't see the word or, it is an and. So let's go back to the conjunctions. Again, what's going to happen is you're going to have two inequalities that you're going to solve down. So let's work on the one on the left first. We'll just minus 1 from both sides. And so we'll have 3x is greater than negative 6. Divide both sides by 3. And we'll have x is greater than negative 2. So that's part of it. That's only part of it. It's only half of it. When you're dealing with a compound inequality, remember there's two parts. So let's go to the one on the right. Let's minus 5 from both sides. And so we'll have negative 2x is greater than 2. Divide by negative 2. And we'll have x is less than negative 1. Now, this is called a conjunction for a reason. Can you remember in your head conjunction and converge? Because that's what your graph is supposed to do. Okay? If you have a conjunction, your graph should converge, come together. Okay? So now what's going to happen, instead of having one number in question, we have two numbers in question. Let's put those on the graph. So we have a negative 2 and we have a negative 1. X has to be greater than but cannot be equal to negative 2. So we're going to have a parenthesis going to the right. That's the one. That's this one. Okay? Now, the one on the right says, this one, x has to be less than, not equal to, negative 1. So we're going to go this way. Now watch. If I start coloring, the graph is going to converge. And that's exactly what should happen. Anytime you have an and statement, your graph should converge, come together. Okay? If they don't, then something went wrong in your algebra and you need to go back and fix it. So, interval notation. Remember there's three things. You got to solve, graph, and write an interval notation. So interval notation, same thing. We're going to read from left to right. So this is going to go from negative 2 to negative 1. And we cannot include either one of those, so we're going to use parentheses. Okay? Now, with a conjunction, like I said, you'll either see the word and you'll solve it like we did here, or you won't see the word and. And if you don't see the word and, it's a little more difficult for some. So, this is a conjunction. And let me show you how to write it to where it may be easier for you to solve it. You're going to use this middle portion twice. Watch this. You're going to have negative 17 less than or equal to 3x minus 2, and, there's your word and, 3x minus 2 less than or equal to 10. Okay? So it is a conjunction, we're just not writing the word and. It's all put together. But if you want to write the word and, if you want to separate them so it's easier for you to solve, then that's what you're going to do. Now, if you don't want to do that because you're a novice or an expert at this, then this is what we're going to do. Remember at the beginning, we kind of did these lines. Same thing. This time, whatever you do in the middle, you have to do on both sides. Okay? So the first thing we're going to do is we're going to add 2 to both sides. In the middle and either side. So if we do that, we're going to get negative 15 less than or equal to 3x less than or equal to 12. Now to get x by itself, we're going to have to divide everything by 3. Alright, so if we divide everything by 3, we're going to get negative 15, negative 5 less than or equal to x less than or equal to 4. How do we do? What you got? Good. Alright, so on the graph, we have a negative 5 and a 4 in question. This time, we can be equal to, so we're going to use brackets. So we're going to bracket to the right, bracket to the left, and color in between. And I like writing the conjunction statements like this because it kind of helps you see x has to be in between negative 5 and 4. Can you see that? X has to be in between negative 5 and 4. And so when you do that, it's easier to put it on the graph. And when you put it on a graph, it's easy to write it in interval notation. You just read the graph from left to right. Okay? But again, if you don't want to solve it with this setup, that's fine. Just make sure you use that middle part twice and break it up with the and statement. Okay, disjunction. Again, if it's a disjunction, you have to see the word or. If you don't see the word or, it cannot be a disjunction. Okay, you have to see the word or for it to be a disjunction. When you see the word or, you're going to do the exact same thing as you did with the conjunctions. You're going to solve this one, and then you're going to turn around and you're going to solve this one. Now, remember conjunction, converge, disjunction, diverge. Disjunction, diverge. So they should go away from each other. So, if we solve this, we're going to have add 5 both sides. You should already be working on this. 2x less than negative 6. Divide by 2. You get x less than negative 3. Should already be ahead of me. Should already be working on this. One on the right, we're going to minus 1 from both sides. And so we'll have 5x greater than or equal to 5. Divide both sides by 5. You'll have x is greater than or equal to 1. Okay, now, let's put this on the graph. Since it's an or statement, you should see this graph go away from each other. Don't take that for granted, okay? That's a way to check your answer. So, for example, the one on the left says that x has to be less than negative 3. So far, so good. We're going to have a parenthesis and we're going to go less than. So that's going away from the other one. That's good because we're going to negative infinity. Then the one on the right says that x has to be greater than or can be equal to 1. Greater than means we're going to go to the right. So that's good. So you can see that it does diverge. Now, what about that space in the middle? Well, that space in the middle, if you pick, for example, if you choose 0, it's not going to work. You'll get a false statement. So all the numbers from negative 3 to 1 won't work. Now, interval notation. What we're going to do, I'm going to come up here in the middle and write this. For interval notation, at negative infinity, you know you're going to have a parenthesis, right? We can never do infinities. We can never reach infinities. So we have negative infinity all the way to negative 3, cannot equal. And then we're going to do another one from 1, and it can be equal to, all the way to positive infinity. Can't be equal. But somehow or another, we've got to put these two answers together. And what you're going to do is you're going to use a union symbol. It's a cup, a U, whatever. It's a union symbol. When you look in the book, That's what you're going to see. Try it. And then just look up here and check your answers, see if you got it right. This is a disjunction. I'm going to solve the left hand first, so I'm going to minus 1 from both sides. So we're going to have 3x less than negative 2 divided by 3, and we'll have x less than negative 2/3. Don't turn the inequality around because you're not dividing by a negative number. Okay, on the right, so we'll minus 2 from both sides. So we'll have 3x greater than negative 1. Divide both sides by 3. And we'll have x is greater than negative 1/3. Alright, so to put this on a graph, what two numbers are these two numbers in between? What two whole numbers are these two fractions in between? Very good. 0 and negative 1. Which one's closest to 0? Very good. So we'll have negative 1/3. And then, of course, 2/3. 2/3 is almost 3/3, which would be a whole, right? Yes. And on the test, you're going to have, the test is going to have the number lines on there for you. So, I mean, it's, the whole numbers are going to be there. So, it's good to go ahead and practice it on your study guide. Alright. So, x is going to be less than negative 2/3, so we're going to go to the left. That's good. X is going to be greater than negative 1/3, so we're going to go to the right. That's good as well. So we're going to go from negative infinity to negative 2/3 union negative 1/3 to positive infinity. Any questions? Good. All right. So the last thing we're going to talk about is equations and inequalities, which we've already covered intensely. But we're going to involve absolute value, which kind of throws a hitch in some things. Okay? Again, this is something new. We haven't done it in, we did not do it in 098. For those of you coming out of high school, should be fresh on your mind. But just keep in mind that this is something that's a little bit different, but you can do it. Remember we talked about absolute value very first day. Absolute value is a distance. It's how far a number is from 0. Okay? So what we're going to do is, what's different is the fact you guys have dealt with numbers in the absolute value. So for example, the absolute value of 2 is, and the absolute value of negative 2 is still 2. Right? No matter what, 2 is 2 units from 0, and negative 2 is 2 units from 0. So the absolute value is still 2, irregardless. Well, so this time we're going to turn it around. It's asking you what number is 2 units from 0. Or in this case, what numbers? What numbers are 2 units from 0? Well, you got 1 to the right-hand side of 0, and you have 1 to the left-hand side of 0. So it's 2 and negative 2. Having said that, 95% of the time, and I'll explain to you why in a second. 95% of the time, when you solve an absolute value equation or inequality, you should get 2 answers. And this is why. You should get 2 answers. The only time that's not true is if you're equal to 0. Okay, that's the only time that you're not going to get that. All right, so what we're going to do, here are your steps. To solve an equation, we're talking about equations first. We'll go to inequalities in just a minute. To solve an equation that involves absolute value, first thing you want to do is you want to make sure the absolute value bars, the absolute value group, is by itself on that side of the equation. Because look at this. look at the difference between these two problems. The one on the left, it's ready to go. The absolute value group is by itself on the left-hand side. But look here. Before you start solving this, you've got to get rid of this -6. The absolute value group has got to be by itself before you start solving. Okay? So you're just going to add 6 to both sides on that one. All right. So step number 1, make sure the absolute value group is by itself. Then what you're going to do, and this is what everybody forgets, and that's why I stress there should be 2 answers. Because what you're going to do is you're going to set your absolute value group to both the positive and negative of the number on the right-hand side. Because of what we just talked about right here. So now you have 2 equations. Solve them down, and you'll get your 2 answers. All right? So let's do the first one here. Absolute value group is already by itself, so I don't have to worry about that. Then what I'm going to do, step number 2 is so important. Step number 2, well, it's all important. 3x minus 4 is equal to 14. Write it just how you see it. And then 3x minus 4 is equal to -14. Because from 0, what 2 numbers are 14 units away? 14 and -14. So you got to include both of those. All right, so solve down. We'll add 4 to both sides. And so we'll have 3x is equal to 18. Divide by 3. And you get x is equal to 6. On the right-hand side, we will add 4 to both sides. And so we'll get 3x is equal to -10. Divide both sides by 3. And you get x is equal to -10/3. Now this is what I want you to do. Really quick, in your head. What I want you to do is I want you to take this 6 and plug it in here and tell me what you get. 3 times 6 is 18 minus 4 is, absolute value of 14 is 14. Take -10/3, may take a little bit of thinking. -10/3 and plug it in here. 3 times -10/3 is what? -10 minus 4 is what? -14, but the absolute value of -14 is? And that's why you gotta have 2 answers. You gotta have those 2 answers. Okay, the one on the right, what did I tell you to do? You are listening, yay. Add 6 to both sides. You've got to get the absolute value group by itself before you start splitting anything up. So now we're going to have the absolute value group is equal to 4. Now that the absolute value group is by itself, we're going to say x plus 2 is equal to 4, just like you see it. And x plus 2 is equal, not -6, to -4. Alright, so let's work these down. We'll minus 2 from both sides, and we'll get x is equal to 2. Minus 2 from both sides here, and we'll get x is equal to -6. And both of these are your answers. Not these. Your equations you won't ever put on a number line, because if you did, if you put it on a number line, it'd just be that. Yeah, and we're not going to do that. But the inequalities, yes, we are. And here we are. So to solve an inequality that involves absolute value, same steps. Isolate your absolute value grouping. Write the inequality exactly as you see it and solve it now. And then if you want to, I won't. But then you're going to look at step number 3. Remember when we're solving equations, I told you write it exactly how you see it and then write the opposite? Look at step number 3. Write the inequality with the reverse symbol and the opposite sign. So this time, if you have a greater than symbol, when you write it with your opposite, you're going to have to turn it around. And we talked about that the other day, about being on the other side of the number line. That's why. All right, now, let's think for just a second. Think about what this is asking, because if you can think about what it's asking, it's not going to be difficult for you, okay? Think about what this is asking. This is asking you what numbers are a distance less than 2 from 0. You understand that? What numbers are less than 2 units from 0? What numbers are less than 2 units from 0? Can you tell me? -1, 0, and 1. That's it. So this would be a conjunction. This would be a conjunction. So all of your less thans are going to be conjunctions. If we graph this, watch this. -2 and 2. X has to be greater than -2, but less than 2. And you are going to write it in interval notation. So when you see less than, just think it's going to be a conjunction. Look at this one. Again, think about what it says. All numbers greater than 1. All numbers greater than 1 unit from 0. All numbers greater than 1 unit from 0. So that's from 1 all the way to positive infinity, and from -1 all the way to negative infinity, right? All those numbers are more than 1 unit away from 0. So greater than is going to be a disjunction. Greater than is going to be a disjunction. So I have -1 and 1. X is going to be less than -1, so we're going to go this way. Or X is going to be greater than 1. So we're going to go that way. And then, of course, you're going to have from negative infinity to -1, union, from 1 to infinity. So less than is going to be your conjunctions. Greater than is going to be your disjunctions. Let's try it. For the first one, you have your absolute value grouping already by itself. So you're just ready to start setting it up. So you're going to have x plus 1 is less than 8. And notice I dropped the absolute value bars. And then you're going to have x plus 1 is greater than -8. Okay? When you see those absolute value bars, you need 2 separate problems. One just like you see it, and then the other one is going to be opposite sign and turn that inequality around. All right, solve these down. So we're getting x is less than 7, and x is greater than -9. Now when we put this on a graph, just by looking at this, I see a conjunction because it has to be less than. It has to be a smaller distance, so it has to be less than. So I see a conjunction. So when I put this on the graph, x is greater than -9, that's good. And on the left, x is less than 7, that's good. And so I get from -9 to 7. Now the second problem. What would you do first? Add 3 to both sides. You've got to get that absolute value by itself first. So now we'll have the absolute value of x plus 7 greater than or equal to 7. What's the next step? Yeah, you're going to split them up, right? Your next step is going to split them up. So you're going to have x plus 7 is greater than or equal to 7. Write it just how you see it. And then you're going to have x plus 7 is less than or equal to negative 7. So write it just how you see it, and then on the other side of the number line, when you change your sign, make sure you turn that inequality around. Alright, so let's solve this. We'll minus 7 from both sides, and we're going to get 0, and that's okay. And here we'll minus 7 from both sides, and we're going to get x is less than or equal to negative 14. Question, how many units are from 0 to 14? 14. How many units are from negative 7 to 7? From negative 7 to 7? 14. Does that make sense to you? Okay. Put it on a number line. So we'll have negative 14 and we'll have 0. For this one, just by looking at this greater than symbol, I know that it should be a disjunction. Should be a disjunction. Let's try it. X is going to be less than or equal to negative 14, so that's going to be a bracket going less than, so that's good. X is going to be greater than or equal to 0, so we're going to go to the right, so that's good. It is a disjunction, so we did it right. So we have a negative infinity all the way to negative 14, and we are going to include union, pick back up at 0, and go all the way to infinity. So with these, there's a lot of different ways that you can check your answer. Number 1, figure out if this should be a disjunction or a conjunction, and then go with your graph accordingly. Okay, this is the last thing we're going to talk about as far as Chapter 2 is concerned. You will see something like this on your test. When you start going through your study guide, if you choose to do your study guide, you will see something like this. The directions on the study guide, I think, say solve these problems by inspection only. So in other words, you're just going to look at them and be able to see what the answers should be. On the test, I'm not going to give you that hint. Okay, on the test, you got to figure it out. You will see one of these on your test. So what's going on? Let's think. Got to think outside the box here, okay? I know that's hard, but you can do it. Number 1, all equations of this form, absolute value set equal to 0, is only going to have one solution. Because how many units is 0 from 0? 0. It's one answer. So only one number is going to make this true, and that's going to be your negative 3. So if it's set equal to 0, only expect one answer. Every other time, though, how many answers should you get? 2. Please remember that. Okay, look at this one. Think about it. Think about it. All equations of the form an absolute value. Every time you take an absolute value of any number, what should you always get? 0 or a positive number. Look at this. Absolute value set equal to a negative number. Is that even possible? Will you ever get a negative number when you take the absolute value of something? No. Therefore, your answer is no solution. No solution. So if you see an absolute value set equal to a negative number, and you saw, now look, this is what's going to get you on the test. Watch this. If I take this absolute value, and I start solving it just like normal, I'm going to get an answer. Plug one in here. 2 times 1 is 2. 2 minus 5 is negative 3. But the absolute value of negative 3 is what? 3. Can't happen. So when you see this on the test, you have to know the absolute value can't be negative. Otherwise, you're going to solve it like normal, and you're going to tell me this is the answer, and I'm going to mark it wrong. Okay? So be careful with that. Be careful with that. Okay. Look at number 3. Inequalities. Absolute value less than a negative number. It's the same concept. What numbers are less than negative 4? negative numbers, right? Negative numbers are still less than negative 4. If you're at negative 4 and you want to go less than, you're still talking about negative numbers. Well, we just had an elaborate discussion about absolute value cannot be negative. So again, no solution. No solution. If you set this one up, you will get answers. So be careful. If they're wrong, the answers are wrong. But you will get them. Okay, look at this one. Absolute value greater than a negative number. When will that ever happen? Absolute value greater than negative 1. When will that ever happen? Every time. Always. Always. Therefore, your solution, all real numbers, any number you want, however you want to write it, I don't care. All real numbers. Now, when you check your answers in the back of the book, for no solution, you're going to see a 0 with a line through it. That means no solution. For all real numbers, you're going to see from negative infinity to positive infinity, you may see a double bar R, or you may see this written. Just to give you a heads up of the way that the answers can be written. Okay? Now, like I said, here's your study guide. If you do this study guide completely, show all your work and everything else, then I'll give you up to 10 bonus points at my discretion. Your test is Wednesday. You will have a Chapter 2 test Wednesday. The other thing, some of you came in late, so I'll just go ahead and tell you again, remind you. If we miss a class, that lecture will be on Tegrity, and it will be your responsibility to go on Tegrity and get that lecture. Understood? Y'all are packing up, and I have 20 minutes. Why are you packing up? I have 20 minutes. 20 minutes. All right. So, this is where your test will end. But since we lost time, you know what I'm going to do, right? As far as your test goes Wednesday, Chapter 3 will not be on it, except you'll have 2 bonus questions from the Chapter 3 material that we cover. Okay? 2 bonus questions. So there is a possibility of 20 bonus points on this test. That's crazy. I might have to rethink that. Alright, Chapter 3, Polynomials. Let's start off with, and this is 098 stuff. You should remember this, so this should be in your brain. Single terms that contain variables with only whole numbers as exponents are called monomials. Monomial, one term. How do I know I'm looking at a monomial? No addition and subtraction signs. If you don't see addition and subtraction signs, you're looking at a monomial. Now, what I'm going to do is I'm going to ask you to classify polynomials. Classify polynomials. Well, monomial is a classification. It's just like if you were in biology class and they asked you to classify a dog, and it would be something canine, something, 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 something. Yeah, I don't know all the kingdom and phylum things. Same thing. It's the exact same thing. So a monomial is a classification of these. If you don't see any addition and subtraction signs, it is a monomial. Mono means one, so you have a single term. The other thing I'm going to ask you for is the degree. If you have a monomial, all you have to do is add your exponents. All you have to do is add your exponents. So the coefficients are irrelevant. The coefficients are irrelevant. So watch this. The degree of this first monomial, you have an x to the first and a y to the first. 1 plus 1 is? So your degree is 2. Okay? The second one, you have a to the second, b to the first. So your degree is going to be 2 plus 1, 3. Now, number 14, watch this. Anything, think before you speak because I don't want you to embarrass yourself. Anything to the 0 power is what? 1. Anything to the 0 power is 1. So watch this. 14 times x to the 0 power is 14 times 1, which is 14. So if you just see a constant, the degree is 0. All right, we have x to the first power, so this is degree 1. So on the test, not Wednesday, but on your next test, we're going to add, subtract, multiply, and divide these polynomials, and I'm going to ask you to classify and tell me the degree of your answer. Okay? So if you just get one term, it's going to be a monomial, and then to get the degree, you're just going to add its exponents. But what happens if you get into addition and subtraction signs? What happens if you have more than one? Well, we've already discussed this. Mono means one term. Bi means two. There's your subtraction sign. It could have been a plus sign. It doesn't matter. But you have 1, 2 terms. There are 2 terms there. Tri means 3. Tri means 3, so you have 1, 2, 3 terms. Now, I know the Latin prefixes, so if you want to use them, fine. But we're just going to agree that anything above 3 is going to be a polynomial. Poly means many, and so 4 terms or more is just going to be a polynomial. Now, you will hear me say when we start factoring in the latter part of this chapter, yes, we are going to factor in the latter part of this chapter. Aren't you excited? You will hear me say that a 4-term polynomial is a quadrinomial, but anything above 3, if you write poly, I'll be happy. But if it's 1, I want to see the monomial. If it's 2, I want to see binomial. If it's 3, I want to see trinomial. Okay? Anything above that, you can write poly, or you can write quadrinomial, whatever. So these are the classifications. Classify. All right, and then the degree. For the monomial, we've already talked about. You're just going to do 3 plus 4. The coefficients are irrelevant. They're irrelevant. Don't even worry about them. So you're at 3 plus 4, which is going to be 7. Now, this is what I want you to look at. Anything that's not a monomial, you have to look at each term separately. And the highest degree term is the degree of the whole entire polynomial. Okay? So watch. You see this 3 over here, yes? The degree of this binomial is 3. No way in the world did I come up with 3 by adding 2 plus 1 plus 1 plus 1. That seems to be 5. Okay? The degree of this binomial, the degree of this monomial is 3. The degree of this monomial is 2. You take the highest degree, and that's the degree of the whole entire thing. Okay, so now we know. So look at this one. The degree of this one's 2, the degree of this one's 1, the degree of this one's 0, the degree of the whole entire thing is 2. Do you understand what we're doing?
So it has to be
The highest one. You take the degree of each term. You take the degree of each term. Find the highest one, and that's your answer. Don't add all of them together. Okay? Now, you know how to do this. To add polynomials, you're just going to combine like terms. What we have here is we have 2 different groups. And I want you to add those 2 groups together. Do it. Add those 2 groups together. Now this is where the coefficients do come into play, but the exponents don't. The exponents are going to stay the same. The coefficients are what's going to change here. When you start adding and subtracting, the coefficients change, but the exponents stay the same. We did this in chapter 1. How many x squares do you have? You have 11x squares. How many x's do we have? And how many constants do we have? Okay, now this is what it's going to look like. You ready? I'm going to ask you to classify, and it's going to have a line by it. I'm going to ask you to tell me the degree, and then, of course, your answer, which your answer is right there. You have 11x squared minus 4x. Let's do a plus 5. Classify. Good. And what's the degree? Easy bonus points, right? Easy bonus points. Okay, do the one on the bottom. How many x squared y's do we have? There's -4, there's 7, and there's 5. So all total we have 8. Okay, let's go with xy squared. How many total xy squares do we have? So we have 1, right? If you see 1, there is 1. So we have 1, -9, and -4, which is going to be a -12. Classify. And degree. Look, if there is 1, you see 1. Or if you see 1, there is 1. So you're going to have a degree of 3. Good. Notice, as long as we're combining, adding and subtracting, notice we didn't do anything with those exponents. They did not change. Right? Did not change. See if you can do this one. See if you can set it up correctly. There's a trick. You'll read the slide. It'll kind of help you. So when you set this up, if it's in word form, you have to be careful with subtraction. Addition, it doesn't matter. Addition is commutative. You can write it any way you want to. But with subtraction, you have to be careful. If you see the word from, you're going to have to flip-flop. Okay? Because it says subtract this from this. So the 7x squared minus 2x minus 4 has to come first. Minus the 3x squared plus 7x minus 1. Now, this is Math 100, so I'm not going to actually apply this. You can do what you want. Okay? I feel like everybody sitting in this room is to the point that you can subtract 2 polynomials. Just make sure that you take this subtraction sign all the way through. Make sure you apply this subtraction sign all the way through. So, how many x squares do we have? 4. 7x squared minus 3x squared is 4x squared. How many x's do we have? -9. Watch this. -2x minus 7x. -2x minus 7x is -9x. And then for your constants, you have -4 minus a negative. What happens there? You got a plus. So we have -4 plus 1, which is going to be... Okay, so here's my answer. Classify. And the degree. Good job. Very good. Try this one. How many a squares do we have? 5a squared minus 2a squared is going to be 3a squared. How many b's do we have? -2 plus -7, -2, there's not any here, plus -7. It's going to be -9. And what about our constants? You have a negative, or subtract the 4, minus a 4, and then a -3. So you basically have a -4 and a -3, which is going to be a -7. Classify and degree. Is it always going to be that way? No. It just so happens that these are that way. Alright, we'll save this because it'll take a while.